Hi everyone, it's Miss Chang and I am here to talk to you guys about rate of change. So please make sure that you have the notes from the sub, the rate of change notes sheet, and also make sure that you have your Unit 4 toolkit out. And we're going to start with the toolkit definition, okay? You're going to follow along with the video and fill in the note sheets as you go. So first thing, definition, rate of change. A rate of change is a rate that describes how one quantity changes in relation to another quantity. So in other words, we have two different quantities that are changing. It might seem kind of complicated, but it's super simple. You guys have seen rates of change a million times, okay? Here's a couple examples. When you go grocery shopping, you're buying fruit. You might want to buy some apples, and your apples might be $2.99 per 1 pound, right? When you go shopping at a store, you might see a sale that says t-shirts on sale for $10 per shirt, right? So it's one quantity changing in relation to another quantity. In other words, the price is changing by $10 for each additional shirt that you buy. When we drive, we measure how fast we drive, our speed, in miles per hour. I might be driving 20 miles per hour. In other words, I'm going 20 miles every 1 hour. All right? So a rate of change is describing how one quantity, in this case maybe money, changes into another in relation to another quantity, so number of shirts maybe. So really, another thing you can add to your toolkit, a rate of change is really just a slope with units. Slope with units. So we're going to practice finding rate of change a couple different ways. So that's it for the toolkit. You can push that to the side and on your notes. We're going to talk about finding rate of change from a graph. So here's this graph over to the right. You have the number of miles traveled on your x-axis and the gas in your tank, that's on your y-axis. What's happening to the gas in the tank? As in the gas of the tank, that's your y, it's going down. What do you notice about the miles traveled? That's x. We're traveling more miles, right? So miles are increasing. So what happens as the miles traveled increases? So as miles are increasing, in other words, as we're increasing that way, the gas in the tank is decreasing. Makes sense, right? The farther you drive, the more gas you use, so you have less left. Question D, what's the rate of change? The rate of change, again, slope with units. Now you guys practiced counting rise over run for rate of change, right? So we're going to do the same thing here. We're going to count rise over run from this graph. Just be careful though, not all of these blocks necessarily represent 1. So as I go down here, I'm going down 2 units, and as I count across the blocks, I'm going over 50 miles. So if I were to just think about slope, I went down 2, but what are the units? 2 gallons. So I went down 2 gallons and I increased 100 miles. So just like with slope, I need to reduce this fraction. So -1 gallons per 50 miles. So this is my rate of change. Notice it's just a slope with units. Explain what it means in the context of the problem. So this tells me that I use 1 gallon of gas for every 50 miles that I drive. And when I say use, that tells me it's going down, right? That's because the rate of change is negative. Let's go on to the next problem. The graph at the right shows play attendance over a 10-week span. So you can see that this rate of change, I have 3 different rates of change. One here, and one here. 3 different slopes to my line, right? So let's find the rate of change from weeks 1 to 4. Now here we have a graph again, but here's weeks, and that's my x-axis. Between weeks 1 and 4, these points don't hit the grid marks evenly. So instead, I'm going to have to use the coordinates of the points that are given to me. Again, rate of change is just slope with units. So think about slope. y2 minus y1 over x2 minus x1. So my rate of change is going to be 232 minus 124 over 4 minus 1, right? Now let's think about units. The 232 and the 124, that was listed as attendance. Well, what's attendance? Attendance are people. And 4 minus 1, that's weeks. So I now have to simplify. I get 108 over 4 minus 1 is 3. Now, check and see if that can be reduced. It can. So this reduces to 36 people per 1 week. So if I were to ask you to interpret that, that tells you that between weeks 1 and 4, we have 36 additional people coming to the play every week. All right, now you try from weeks 4 to 6 and weeks 6 to 10. Pause the video for a second, try those 2 problems, and then resume it and you can check your answers. All right, so here's your answers from weeks 4 to 6 and weeks 6 to 10. Again, keep in mind you've reduced these fractions, right? The fact that these 2 rates of change are negative tells me that I'm losing people. This one right here, this tells me that every week I have 14 less people than I did the week before. Or in other words, my attendance is decreasing by 14 people for each week. All right? Now that you've done those couple problems, take a minute and try the you try problems. All right, now that we have found rate of change from a graph, let's try getting rate of change from a table. Keep in mind, a table is just a whole bunch of points, okay? So the table shows the amount of money a booster club made washing cars for a fundraiser. Use the information to find the rate of change in dollars per car. So first of all, here's a little hint. They tell me rate of change in dollars per car. So they're giving me a big hint there. That tells me the dollars have to be on the top and the cars have to be on the bottom, right? So keep that in mind. Slope, what goes on the top of the fraction? X or Y? That's our Y. The Y goes on the top, the X variable goes on the bottom. But think about this. Let's think about this table here, okay? We have cars washed, and we have a certain number of cars in the left-hand column and the amount of money we make. In order to determine which one's X and Y, you have to think about which one is the independent variable and which one is the dependent variable. What depends on what? Does the amount of money that you make depend on the number of cars you wash? It does. That makes sense. So because of that, the amount of money is your Y, your dependent variable, and the number of cars you wash is your X. So you can see in this table, they tell me that the Y's are increasing by 40 every time, and the X's are increasing by 5 every time, right? So what's the change in the amount of money? It's increasing by $40, so it's positive. What's the change in the amount of cars? It's increasing by 5 cars, it's positive. Notice that I have some units in there, right? So to find my rate of change, I need the change in money. Again, that's $40, divided by the change in cars, 5 cars. Well, now if we can, we're going to reduce that. We can. So $8 per 1 car. Do I really need that one? No, I don't. So I could just have $8 per car. So this is my rate of change. Explain your answer in the context of problem. This is telling me that I make $8 for every car washed. Notice that you read rates of change kind of like you read words. Okay, I can always stop at the top. I can always start at the top. So I make $8. The fraction line, you can use either word for or per. So it's $8 per car. Make sense? All right, let's do one more problem together from a table. So again, these are a bunch of points. The number of miles a plane travels while in flight. So use the information to find the rate of change in miles per minute. Again, that's a big hint, right? Let's think about what's X and what's Y. Does the distance depend on how long you've traveled, or does the length that you traveled depend on how far? The distance is dependent upon how long you've traveled. So this is X, this is Y. Think of these as a bunch of points. I have the point 30, 290, 60, 580, 90, 870, and 120, 1160. I can use any of these points. I'm going to just use these first two, right? Again, rate of change is like slope with units. So I'm going to plug in 580 minus, 580 minus 290 over 60 minus 30. And 580, what are the units there? That 580 and that 290, that was miles. And the 60 and the 30, that was measured in minutes, right? So I'm going to plug this into my calculator. 580 minus 290 is 290 miles. 60 minus 30 is 30 minutes, right? That doesn't go in evenly, but I can reduce it. They both end in a 0, so that I can divide by 0. So this tells me my rate of change is 29 miles per 3 minutes. And again, if I were to interpret this or explain what it means, I would say that the plane travels 29 miles per 3 minutes. Or the plane travels 29 miles every 3 minutes. Or the plane travels 29 miles for every 3 minutes. Make sense? All right, take a minute, pause the video, try the you try problems. Last thing we're going to do, we're going to try and find rate of change from a scenario. All right, so think of it as like a word problem. So number 10, Miss Esposito is collecting stuffed animal cats. After 3 weeks, she has 10 stuffed cats, and after 12 weeks, she has 100 cats. Find the rate of change in cats per week. Again, there's my hint, cats per week. So this probably tells me that this is Y and this is X, but let's think about it. My two variables that I have here, they tell me after 3 weeks, she has 10 cats. And after 12 weeks, she has 100 cats. My two variables, the things that are changing, are the number of weeks and also the number of cats, right? So a lot of times when we have time as a variable, that's going to be our X variable. So I'm going to say, oops, this isn't letting me write in here. I'm going to say that X is the number of weeks and Y is the number of cats. All right, and I'm going to take this information that they told me in these couple sentences and I'm going to write this as points. After 3 weeks, she has 10 cats. And after 12 weeks, she has 100 cats. There's my 2 points. Plug into your slope formula, y2 minus y1 over x2 minus x1. So 100 minus 10 over 12 minus 3, right? Think about the units before we go any further. The 100 and the 10 were the number of cats. The 12 and the 3 were the number of weeks. So let's simplify. We have 90 over 9, right? Does that simplify or reduce? It does. It gives me 10 cats per week. So what does that mean? It means that Miss Esposito is collecting an additional 10 cats per 1 week. So again, one more time, here's a you try problem at the bottom of your page. So take a minute, try that problem. All right, guys, that wraps it up for rate of change. Feel free to go back and rewatch this video at any point. Make sure that your notes are completely filled in. You need to do all of the you try problems. We're going to check to make sure that your notes are completely filled in, and make sure you get your homework from Miss Fred or from the sub. Thanks, and have a great day.